Okay, we continue with programming timers 0, timers 1, and also timers 2. Okay, so for the introduction, we know that every timer needs a clock pulse to tick. So the clock source can be either internal or external source. If you are using the internal clock source, means that you are using the frequency of the oscillator fed into the timer for the time delay generation. Okay, so for the when you use the ATMega32 microprocessors, you can see there is the X style. Okay, so this pin name is referred to the oscillator. And next we have the external clock source. This is we feed pulses through one of the AVR pins as a counter. Okay, so if we are using external clock source, means that you want to do the counter. So for example, you use a switch, so once you press the switch one time, means that your counter count 1, something like that. And then in Mega32 we have 3 types of timer. Okay, so it is either timer 0, timer 1, or timer 2. So timer 0 and timer 2 are 8-bit, while timer 1 is 16-bit. Okay, so this timer we use is either for time delay or as a counter. Okay, so the basic registers for the timers, so for the basic registers and flags that are associated with the timers in ATMega32, we have TCNT, okay, TCNT, TCCR, OCR, and also TIFR. So here the name indicate TCNT, timer or counter register. Okay, CNT is counter, T for timer. Okay, timer, counter, control register, output compare register, and we have timer, interrupt, flag registers. So here for the flag, we will see the timer, overflow, and also output compare flag. Okay, so the N, okay, the N here is refer to the timer that you're going to use. Either timer, if N is 0, you means that you are using timer 0. Okay, so in the previous slide, timer 0 is 8-bit. Okay, 8-bit. So if you are using N equals to 1, means that you are using timer 1. So all of these registers and flags must be, you put number 1 at the back. So for example, you have TC and T1, means that you are using timer 1 concept. Okay, so if you are using N equals to 2, means that you are using timer 2 for your program. Okay, so we look forward into this. On the right side, this is the ATMega32. So for timer 0, timer 1, timer 2. So for example, you are using timer 0. Okay, so timer 0, if we refer back to the basic registers and flags over here. Okay, so firstly, we see the TCNT register. So what is the TCNT? It is a timer counter register. So here, timer counter registers. So if TCNT, okay, for example, here I use TCNT 0, so you refer to the timer 0. So if you are using TCNT 1, you refer to the timer 1. And then if you are using TCNT 2, means that you need to, you want to do the timer 2. So what is it actually? So we refer to the text first. Okay, so TCNT registers is actually a counter. So upon reset, so when you reset, the TCNT is 0. However, every pulse, okay, every pulse, either it is internal pulse or external pulse, the count will increase. So therefore, the content, okay, the content can be accessed by loading a value to TCNT or read we load it or we want to read it. So it depends on what is your purpose. And then we have TCCR registers. So this is for setting modes operation. So if we specify, if we want to specify, we want to use the timer 0, we just put TCCR equals to 0. Okay. And then OCR, output compare registers. And then TIFR, we have the TOV, we have the flags, and also the output compare flags. Okay, so we see here, for example, you want to use timer 0. Okay, timer 0 is 8-bit. So we want to use the TTCR 0. Okay, so the setting modes of operation is TTCR 0. So we see here we have TCNT, we also 0, OCR also 0. But then how this process? Okay, so we first so we refer back to the method in the previous video. We have the first method. Okay, we have the first method and also the second method. Okay, so the first method we have the CTC method. Okay, we have CTC method. The second method is overflow method. Okay, so if we want to use the overflow method, okay, I go to the second method first. So if we want to use the overflow methods, means that our overflow flag, okay, this is overflow. So overflow, we need to have the, okay, we check the register overflow, which is TOV flag. Okay, TOV flag will be a set. Okay, so if we are using second method, so TOV will be equals to 1 because we are using the overflow method. But then if we are using the first method, CTC, the overflow register is 0 lah. Okay, so if we are using this, that will be 0. Okay, so the overflow flag will contain 1 because we are indicating the timer 0 using the second method. Okay, so now what happened is that once we want to use this timer, okay, so TCNT, okay, TCNT will the content of TCNT is if we refer back to here, okay, is a number. So if it is a number, then okay, a number, and then if we are using the overflow method, this will be 1. However, if we want to use the CTC method, okay, TOV flag will be 0. So when the TOV flag is 0, we can we need to compare. Okay, we need to compare the TCNT. We compare with the OCR. So OCR is the output compare registers. So we compare what is the content of TCNT and OCR. Is it same? Okay, if it is same, okay, if it is same, the OCF will be 1. If it is not same, okay, if same, will be 1. So if the content inside the TCNT registers and OCR register are different, the value will be 0. The timer 1. Okay, so for timer 1, firstly you see your TCNT value. So for timer 1, okay, you can choose the two method, either the first method, CTC method, or the second method, overflow method. Okay, so if you want to use the CTC method, you check on the TOV flag. Okay, so TOV1, if you are using CTC, okay, so your TOV flag will be, TOV1 will be equals to 0. If you are using the overflow method, okay, your TOV1 will be equals to 1. Alright, and then if you want to use the once you check the TOV value is 0 or 1, so you know that your program or your project will, your microprocessor is doing the CTC method or overflow method. And then if it is if the TOV, okay, if the TOV is 0, you need to check on the OCR registers, so output compare registers. So this for timer 1 you will have 1A, okay, 1A and also 1B. So you will compare the values inside the TCNT1A, okay, TCNT1A. Is it, firstly, if you want to use the if you want to use the TCCR1B, so your TCNT1 register will be compared with the OCR1B registers. So if the value are the same, you compare, therefore OCF1B will be 1. Okay, if it is same, OCF1B will be equals to 1. If the values inside the TCNT and OCR are not same, okay, not same, so the OCF will be 0. Okay, so then you compare with TCCR1A. Okay, if you are using TCCR1A, you need to compare your TCNT1 with OCR1A. So if it is same, OCF will be 1. If not same, will be 0. And then for so if you want to use timer 2, so your TCNT2, okay, TCNT2, it will assess the TOV value first. So what is the value inside TOV flag? So if TOV equals to 1, means that this is using overflow method. If TOV equals to 0, means that you are using CTC method. So if you are using CTC method, you must check your TOV must be 0, and then you need to compare the value of TCNT2 with OCR2. Okay, if the value are same, if it is same, the OCF flag will be set. Okay, set means 1. Alright, so basically that's it. However, you need to know that for timer 0 and timer 2 is 8-bit. Okay, this is in the earlier 8-bit, and this is 16-bit. Okay, moving forward, timer 0 programming. So in ATMega32, timer 0 is 8-bit. So we know that if it is 8-bit, we have from bit 0. Bit 0 is on the most right. Okay, and then bit 8, bit 7. Okay, so this is the first bit. This is the 8-bit. So the first bit is bit 0. It is on the most right of the registers. So bit 8, the 8-bit is the bit 7. It is on the left side of your register. So you fill in from the bit 0 until bit 7. Okay. So next, this is the definition. Okay, so for bit 0, here we have bit 0. So actually bit 0 is CS00. Okay, and then you can read through bit 0, bit 1 until bit 7. So bit 7 is FOC 0. So FOC 0 is here. Okay, CS is here. This is from CS02 and CS 00. So this is over here. Okay, so means that if you want to use the timer or counter, means that you need to check the value of the programming. Okay, timer 0 is 8-bit. Okay, so in ATMega32 it is 8-bit. Moment. It is 8-bit in ATMega32. So for if we want to use timer 0, we just set TCNT 0. Okay, so it has 8-bit registers. Therefore, the most right, okay, this is the bit 1, bit 0. Okay, so this is bit 7. Okay. Okay, so for the content, okay, so what we need to do, what we need to store inside these registers. Okay, firstly we see the bit 0. Okay, bit 0 is CS00, so it is a D0. So the next one is bit 1, so bit 1 is D1. Okay, and then here is the bit 2, D2. Okay, so here the value inside CS, okay, CS00, CS01, CS02 indicate whether we use the timer or we use as counter. So the important values that we need to know is this one. Okay, so if the values are 0, 0, 0, it means there is no clock source or the counter or timer is stopped. Okay, so if it is 0, 0, 1, there is a clock. Okay, there is a clock with no prescaling. So what is prescaling? Okay, later I explain about that. And then if it is 0, 1, 0, means that we have the clock and the prescaling values are 8. Okay, so here the numbers that you can see here, this is the prescaling values. Okay, so if the prescaling is 64, you use 110. Okay, until we have 101, and then the last two here. Okay, the last two here, 110 and 111. Okay, so this is external clock. So what is the external clock? This is refer to the counter. Okay. This is as counter. So if we want to use as, we want to use time 0 as delay, we can use either timer stop without prescaling and also with prescaling. Okay, and then we move forward. There is bit 3. Okay, bit 3. Okay, D3 is here. So here, D3, and there is another one, WGM. Okay, bit 6. Bit 6 and 3 is here. So this bit indicate whether the timer 0 mode of the selected bits. So is it in the normal setting? Is it using CTC setting, or we use PWM or fast PWM? However, for this course, we only focus using two methods. Okay, in the previous slide. So either normal or CTC. So normal is the overflow method. Right, so if we are using the overflow method, we just read the value here at bit 3 and bit 6, the value must be 0, 0. If we want to use the first method or CTC method, we put the D3 as 1 and then D6 we put as 0. So directly we know lah, once we see the bit 3 and bit 6, we know what kind of method that the program choose. Okay, and then for here, the 3-bit on the right is indicate whether it is as timer, as time delay or as counter. Okay, and then for D4 and D5, okay, D4 bit 4 and bit 5, here is we want to see what is the value for the compare output mode. Okay, and then for bit 7, that is here, okay, FOC, force compare match. So this is a write only bit which can be used while generating a wave. Okay, writing 1 to it cause the wave generator to act as if a compare match had occurred. So if it is occur, the value here on the TCCR0 at bit 7 will be equals to 1. However, if it is if there is no compare match, so the bit 7 will be equals to 0. Okay, as simple as that. Next. Okay, so here this here is the value for all of the, this is summarized what is in the table before. How to clean. Okay, so for the CS00, CS01 until CS02, this is for the clock. Okay, the clock, either the clock is delay or counter. And then WGM, is it as overflow method or CTC method or PWM method. So PWM is not covered in this class. However, PWM is pulse width modulation or pulse modulator. So moving forward to the next slide. Okay, so for example, here we have the question asked about the TTCR if we program the using timer 0 in normal mode. Okay. Sorry. Normal mode, what is this? No prescaler. Okay, no prescaler. Use AVR crystal oscillator. Okay. So what is the content inside our TTCR0? So what we can fill in here is, okay, firstly it says in normal mode. So if normal mode, okay, normal mode, we go back to this slide. Okay, so normal mode, you see D3 and D6 are 0. Okay, D3 and D6. So we fill in D3 and D6. So this is D0. This is D7. So here are 0 and, sorry, 1, 0, 1, 2, 3. Okay. D3 are 0. Then D6 also 0 because it is normal. Okay, it is normal mode. And then it says using crystal oscillator for the clock source. So this is internal. Okay, internal source. So means that we are using the oscillator of the microprocessor. So the value, okay, here 0, 0, 1. Okay. Okay, clock source, no prescale. So the value is 0, 0, 1. Okay, what about the others value? Okay, D4, 5, and 7. So D4 and 5 and 7, we see here. D4 and 5, this is to control the waveform generator, and then the bit 7, right one, if we have the wave generator to compare the mesh. So in this question, we don't have that information. So what we can do is we just put 0 to FOC and also COM01 and COM00 because we don't have that information for this question. So the result for our TCCR will be equals to binary, okay, binary 0, 0, 0, 0, 0, okay, 0, 0, 0, 1. Okay, so this is the answer for our TCCR 0. Okay, next question is, okay, next question is with the following crystal frequencies, assume no prescaler is used. So find the timer, clock frequency, and its period. Okay, so F equals to 1 over T. Okay, so here the question gives you okay, for the A, the crystal frequency, so this is the crystal frequency, 10 megahertz, 8 megahertz, and also 1 megahertz. So in order to find the clock frequency, okay, the clock frequency will be equals to crystal frequency. Okay, so directly we write the clock frequency is equals to the given crystal frequencies because no prescaler is used, means that the crystal frequency is not scale into another values, either make it bigger scale or smaller scale than the crystal frequencies value. So we just take directly what is given. Okay, so the first one for the A, F equals to 10 megahertz, and T, okay, the T will be equals to 1 over F. Okay, 1 over F. So you find the value will be 0.1 microsecond for A. And then for B, you have 8 megahertz. And your period, okay, the period or the time, it will be equals to 1 over 8 megahertz. So the answer is 0.125 microsecond. And F, also 1 over 1 megahertz. So you get 1 microsecond.